If you're a software engineer, you're either sitting on the left side or on the right side. Being on the left side means that you're in a team that is in charge of an application or a service that serves end users. Your team should be autonomous. You should be in full control of the life cycle of your application. You and your team should write code, run tests, build stuff, deploy stuff, manage infrastructure, and so on and so forth. What you don't want is to start opening Jira tickets whenever you need something to be done and wait until some other teams do things for you. Like, hey, I need this to be deployed. Let me know when it's done. Or, hey, I need a cluster. Can you please create it for me? I can wait. Your team wants to be autonomous and your team wants to be self-sufficient. On the other hand, if you're on the right side, you're a specialist in something. That could be infrastructure, CI/CD, security, what's not. It could be many different things. What matters is that you're specialized in something. You're an expert in some area that is not directly related with the development of an application. And you do not want others to open Jira tickets. You do not want to spend your time deploying applications for others, creating clusters for others, and so on and so forth. If you're, let's say, an expert in infrastructure, what you do want is to create services that can be consumed by those teams on the left. You want to create a system, a platform of sorts that will enable people on the left, those teams in charge of developing applications, to self-serve themselves. You and everybody else wants to shift left. We want to enable people working on those applications to be self-sufficient. And the key word there is enable. We cannot expect everybody to know everything. There is a reason why somebody is specialized in, let's say, infrastructure. It takes time to master everything there is to master about a specific area or specific subject. And we want to leverage that expertise, but not in a way that experts do stuff for others, but in a way that experts create systems that can be consumed by others. And since we understand that not everybody can understand everything and be expert in everything, those systems, those platforms need to be designed in a way that they fulfill all the needs we have and yet be very easy to be consumed by those who are not experts in that area. We want to create opinionated tools that are easy to consume. And those opinionated tools cannot be bought, cannot be purchased by third-party vendors simply because they do not know what your opinions are. You're an expert. It is your job to generate those opinions, to define those opinions, and do it in a way that it is easy to consume. Software vendors should give you tools to create opinionated frameworks and then give them to the teams on the left. And that's what we are going to do today. Today we are going to explore Crossplane Composites. Now, I already talked about Crossplane. I will not repeat what Crossplane does. If you're curious, if you haven't used it yet, check the video above my head. It introduces you to Crossplane in general. But today we are not going to talk about Crossplane in general. We are going to focus on composites because they will allow us to do something amazing. A quick note. I joined Upbound. Upbound is a company behind Crossplane. And that might make you think that I'm subjective, and I might be subjective about Crossplane, or you might say Victor joined Upbound because he believes that Crossplane is awesome. It's up to you to decide whether I'm subjective and try to sell you something, or I'm working for Upbound because I believe that Crossplane is awesome. So here's what we are going to do. We are going to create a way for developers to create clusters by themselves. We are going to make it extremely easy for them, and yet those clusters are going to have everything that they need to have. And we are going to make them provider agnostic so that those clusters can be created in AWS, in Azure, in Google, or wherever else. In other words, we are going to create complex things that are very easy to consume. We are going to make something that anybody could use, and yet that something is not going to be trivial. For the sake of conversation, I'm going to call people on the left devs and people on the right ops. I know that that's oversimplification. I know that we shouldn't call those groups of people or experts like that. But for the sake of simplicity, if you're in charge of an application, if you're developing an application for an end user, I'm going to call you dev. And if you are in charge of infrastructure, if you're the guru of infrastructure, I'm going to call you ops. So let's explore how ops can enable devs to manage infrastructure. Before I started recording a session, I already created a Kubernetes cluster and installed Crossplane inside that cluster. I'm running a local cluster using K3D. Normally, you would use a real cluster for that if it would be production usage, but for this demo, a local cluster should be fine. Besides installing Crossplane itself, I deployed also providers for AWS, Google, and Azure. You do not need all three of those. You can use only one depending on how many providers you want to use. And I created secrets with authentication to those providers so that Crossplane can do whatever needs to be done. The repository with sample code and all the commands that I executed before this session and that I'm about to execute now are in a gist, and the link to the gist is in the description of this video. I will be using AWS today, but the gist contains instructions how to do the same in Azure or Google Cloud if those are your preference. And if you want to use some other provider, just let me know and I will extend the gist with your favorite provider. So I am an ops person right now and I can say, hey, dear developer, how about you taking a look at this file, cluster.yaml. That file contains everything that you need to know or do to create and manage your clusters. And this is how it looks like, right? I removed all the complexities. I will allow you as a dev person to focus on what matters to you, and all the complexities that you do not necessarily care about are handled by me. This is all you need to know to create a cluster. So what I did as an ops guy, I created a new custom resource definition that is called Composite Kubernetes Cluster. I will show how I did what I did later. For now, I'm focused on what a developer needs to know. You, dear developer, you can change the name. We can keep it Team A. You can change or add labels. Nobody cares about that for now. But what does matter is that here you can choose the provider. You can call it Cluster Google or Cluster Azure or Cluster AWS. Depending on the name of the provider, you will get a cluster in that specific provider. So I, as a dev, can say, oh, that's great. Look at that. I'm going to actually run my cluster in AWS. So I'm going to change this to Cluster AWS. Brilliant. Now there are a couple of parameters that I can tweak to get the cluster I need, the cluster I want. And those parameters are only those that I care about. I can change the size of the nodes to be small, medium, or large. I do not need to know how those sizes translate into specific sizes for specific providers. Is it T2 something or T3 something, or is it this or is it that? No. For me, the only thing that matters is that I can have small or medium or large nodes, and what needs to happen in Azure or Google or AWS is not my problem. I can specify the version of Kubernetes I want to use or leave it empty, and in that case it will be whatever the ops guy decided should be the most appropriate Kubernetes version that I should run. And I can specify the minimum number of nodes that I want to have in that cluster. That cluster will auto-scale. It will not auto-scale to infinity, it will auto-scale to whatever ops decided it should auto-scale, what should be the maximum, but I, as dev, can control what is the minimum number of nodes. And finally, I can choose what is the namespace where the secret with the important information will be stored. That secret might, for example, contain the connection string that I can use, kubeconfig, to connect to that cluster. And what matters for me as a developer and also for somebody else as ops is that this definition was not created by some third-party vendor. This is not what somebody else, somebody outside my company thinks that matters. This is a composite, a CRD that was created by other people in my company, people who are considered experts in managing infrastructure for my organization. Also, one more thing, you can see here that those two parameters are commented. That means that I will use whatever are the default values. Or to be more precise, whatever somebody else, whomever is an expert in infrastructure, thought should be the default values. So in this scenario, I just chose that I want to use AWS and I kept everything else as is. Later on, I might change some parameters, but for now, I do not really care. I just care that I want to create a cluster in AWS. So let's do that. Let me save these changes and I will do kubectl apply --file name cluster.yaml. And now the magic is happening. there is actually one thing that I did not do in this demo, and that's that I do not think that anybody should be executing kubectl this or that. It would be even better if I, as a developer, could just push this manifest to Git repository and not even deal with the kubectl or what's or not. I should just store what I want in a way that is easy for me to understand and manage in a Git repository, and let some other tools, whatever tools there are, maybe Argo CD or Flux or what's or not, manage all that. So I will skip the GitHub story from this demo and maybe explore it in a different video. You just remember that everything I'm doing with kubectl, you should be doing with Argo CD or Flux, and just by pushing changes to Git repository. Now, while everything is being created, let me change the role and show you how all that works if you're an ops guy. How did I get to the point that I can offer something like that to others? What was the process behind it? So I'm an ops guy now. I'm an expert in infrastructure, and this is what I did. I created first the file called definition YAML. And that file defines what will be the interface that everybody will use to create infrastructure. This is not related to any specific provider or anything like that. This is just the definition of the definitions of the manifest that others will be able to create. And what matters here is really this section, which says, hey, I want to create a definition of what the cluster is, and that definition should have 3 properties. It should have a version of the Kubernetes cluster somebody should create, it should have the size of the nodes, and it should have the minimum number of nodes. The minimum number of nodes defaults to 1, and only the size of the nodes is required. So whomever is consuming this has to specify only the node size and nothing else. Everything else can be left as default values, which I will show you later how that really works. And I also defined some properties for the status, which is cluster name, control plane status, and node pool status. You will see the statuses later. Finally, I define additional printer columns, which are more or less the same: cluster name, control plane, and node pool, and you will see later what those are. For now, what matters is that I create a couple of parameters and I wrapped it all up as, where is it? Composite resource definition. So this is a special type of definition I can define in Crossplane, and it is called composite resource definition. It will be a composition of quite a few different resources, and it defines what others can define when working with this composite, which is a few properties, few statuses, and a few columns that should be printed somewhere on the screen. Now, as you already saw, this composite can be used in Azure or AWS or Google. So let me show you how I define providers. And those are all providers that can be used with this composite resource. So let me show you those providers. The provider for Azure, which is the simplest one, I believe, is stored in here, azure.yaml. And this is what it defines. It says, I want to create a composition. A composition is kind of a combination of one or more resources done in a certain way. And I have full control of how that composition should be created and how it works with the definition that we explored a few moments ago. So what do I need when creating a cluster in Azure? I need to have a resource group that's Azure specific, and I need to create an AKS cluster. And here I'm defining what those things are. I will not go deep into how this really works. If you want to have a deep dive into Crossplane Compositions, let me know in the comments. I will do that. For now, I just want you to have a feeling of what is possible. So let's find one interesting example. That could be, here, node size, right? So that parameter that you saw earlier that allows us to specify the size of the nodes, which with values that are small, medium, or large, this is where we map those values into something that is understood by Azure. So I'm saying here, hey, whenever somebody says small, in Azure, that means standard D2, V2, and whenever somebody says medium, that means this, and whenever somebody says large, that means that. Now, this creates a resource group and a Kubernetes cluster in Azure in this case, and we could do so much more. We could install in that cluster whatever our end users need. It could be Ingress, it could be Istio. If developers would always need a database, which could enable them to have a database, whatever is the database service in Azure, and so on and so forth. We could make this as small or as big, depending on what we really need. What do developers need when they need a cluster? It could be many other things outside of that cluster. But for now, I'm keeping it simple. Similarly, I have a file gcp.yaml, which is basically doing the same thing but for Google. It is an implementation of the definition that we saw earlier. And in case of Google, I'm translating that simple cluster definition into whatever Google understands and saying, hey, in Google, we need some resources, which is GK cluster, control plane for GK, and we will need a node pool, and that node pool should be running in those locations. And this is how we translate those sizes into sizes of nodes understood by Google, and so on and so forth. And finally, I created the same thing for AWS. Now, AWS is always complicated. There are usually many things that need to be done to do something successful in AWS. And in case of EKS, we need a route table. And we need subnets, one subnet, second subnet, third subnet. And we need a security group for node pool. And we need a VPC for node pool. And we need some role policy attachments. And we need, what else do we need? Some services, and we need some roles, and we need, what else? Node groups, and EKS cluster itself. Now, this can be complicated, but there is no way around it. I'm an expert in AWS in this situation, and it's my job to understand all those things, but others do not need to suffer through it as much as I'm suffering. So I'm taking all this complexity, I'm defining it here, and developers should still be able to say, hey, I just need a cluster in AWS. I do not care about those things. I care about other things. I care about the size of the nodes and a few other things. Now, if somebody doesn't have that simple file that I showed you initially, the one that I used when I was pretending to be a developer, we could also do kubectl explain, and then the name that I defined, which is composite Kubernetes cluster, and I want to do it recursively, There we are. Now, if anybody is interested, hey, what are the parameters I can use to create those fancy clusters that you simplified for me? Hey, parameters are all here. Look at this section. I can just go and say, explain to me how that composite works and what I should do. And I have all the parameters and all the other details just by saying kubectl explain. I could just as well export this as a documentation. Now let me change my role again and become a developer, the one that actually created the cluster in the first place. And let's see what's going on with my fancy cluster in AWS. So kubectl get composite Kubernetes cluster. I should have made it a shorter name. Here we can see all the clusters that were created as composites, right? With all the complexity hidden. And we can see that in this specific case, the control plane is already active and node pool is being created. Those fields over here are actually fields that I defined as an ops guy. Those are the columns that I said, hey, you should print those columns. And the columns are the name of the cluster, the status of the control plane, and the status of the node pool. And that status is coming from AWS itself. Or if I created the same cluster or similar cluster in Azure, it will be from Azure, and so on and so forth. Now let me show you what's really going on, what is behind that simple definition, which was like 20 lines of YAML, you know, the one that I used as a developer. This is actually what was created. I will execute kubectl, get clusters and node groups and IAM roles and policy attachments and VPCs and security groups and subnets and internet gateways and route tables. All those AWS resources are being created by Crossplane, and I can query the status of all those resources by executing simple Kubernetes commands. And we can see here, hey, those are all the things. This is all that is happening as a result of me applying those few lines of YAML. I mean, me as a developer. And you can see the statuses of all those. They're all ready and all synced except the node group. Node group is still being created. It takes a while in AWS until everything is up and running, probably like 10 minutes or 15 or 20, you never know. So I will wait until my composite cluster is fully operational, and I will do that by outputting the composite clusters. Actually, now it's finished or almost finished. Node pool was not active a few minutes ago, and now it is active. So my cluster should be fully operational. It says ready false, so probably some final touches, final actions are being executed, but my cluster should be fully up and running in a few moments. So let's see if I can connect to this cluster But hey, actually there is a problem. How can I connect to the cluster? What is the kubeconfig? Where is the kubeconfig? If you don't know where kubeconfig is, that's probably because I was too fast when explaining things. It could take a while until I explain everything about composites. But what matters is that kubeconfig is stored as a secret in the namespace that I chose to use, which is theme A. So what I can do to generate a kubeconfig that I can use to connect to that newly created cluster is something like this. I can say, hey, within the namespace theme A, get me the secret called cluster, output kubeconfig. That secret might contain other useful information, but I'm interested in kubeconfig only. I need to decode it, and I will store that output in kubeconfig YAML. And here it is. This is kubeconfig that I can use to connect to the cluster. And if you don't believe me, let's do this. Export kubeconfig equals whatever is the current directory in kubeconfig.yaml. And now I will do something like kubectl get nodes. There we are. This is AWS node because I specified that the minimum number of nodes should be 1. And when I say I mean I as ops specified that as the default value, and I as dev did not change the default value to something else. And just to be on the safe side, let's say kubectl get namespaces, and we can see that, hey, this is my cluster. Now I can use this cluster, and all I did was change 1 or 2 lines in a YAML that is 20 lines or 15 lines altogether. And the next question is, hey, how would I as a developer manage this cluster myself? Do I need to call the ops guys, or should I do it myself? Can I do it myself? And the answer is definitely yes. So let's change something about this cluster and see how maintenance works. I will unset kubeconfig, just to go back to the control cluster where Crossplane is running, and I will edit the same file that I used before, which is cluster.yaml. So what should I do? Yeah, let's say that 1 node as a minimum is not enough. I want to change my cluster to have a minimum of 3 nodes. How would I do that? I would just uncomment this parameter. This is 1 out of 3 parameters in total. That's all I needed as a developer, and I will change the value from 2 to 3. So let's say that I want 3 nodes. What do I do next? As I said before, if I would be using Argo CD or Flux, which I'm not in this demo, but if I would just push those changes to Git repository, and Argo CD would do the trick. It would do whatever needs to be done. By the way, if you want me to show you how to do that, there is a video. I created a video how to control Crossplane with Argo CD. The link is above my head, I think. Anyways, there is no Argo CD, so I will do it manually. Kubectl apply --file name cluster.yaml, and there we go. I just made simple modification to the YAML file and applied this manifest. That's all I did as a developer. It cannot get easier than this. I'm having full control over the things that matter to me, while somebody else, ops, defined everything else. All the complex things that I do not want to care about as a developer, or to be more precise, things that I do not know how to care about. Hey, how many developers understand VPCs and subnets and this and that, all the things in AWS or wherever they are running? I mean, not many, because it takes time to understand those things, and not everybody can spend years figuring it out. That's why we have people that manage infrastructure. But in this case, those people do not manage infrastructure. In this case, people who previously managed infrastructure are now managing services, are managing definitions of what infrastructure is. And I, as a developer, can take full control of it. Actually, not full control, but control over the things that matter to me. Now let me go back to the cluster that I just modified. And let's do kubectl get nodes. Did I get the second node or the third node? Yes, almost. You can see that the second and the third node were created 6 and 9 seconds ago, and they're not yet ready. If I repeat this command, they should become ready in a few seconds. So let's be patient and let's wait until this is fully operational. There we go, the second node became ready, and now the third one should be ready. There we go, my changes were applied. I, as dev, just changed the minimum number of nodes. The last thing I want to show you is, hey, what if I want to delete my cluster? What if I'm finished with the project, or maybe I just wanted to play around? Doesn't matter the reason. What matters is that if I'm allowed to create a cluster and I'm allowed to manage my cluster, I might be allowed or not, depending on the rules that we set. But in this case, I'm allowed to delete the cluster as well. So let me delete the cluster. So let me unset kubeconfig that points to the new cluster. And let's do kubectl delete. And what are we going to delete? Well, whatever is defined in cluster.yaml. The same simple YAML that I used to create the cluster and update the cluster. I'm going to use that file to delete the resource from my control plane type of Kubernetes, the one where Crossplane is running, and then let Crossplane figure out how to delete all the stuff. So here we are, it's deleted. And now if I do kubectl get composite Kubernetes clusters, it's already gone, but is everything gone? Let's say kubectl get clusters. My cluster is still there. That means that not all the resources from AWS were removed. It takes time until you delete things in AWS. What matters is that the fields ready and synced are now set to false. It is not ready, it is being deleted. Actually, let's take a look at all the AWS resources. And here's what's happening, right? If you remember from before, the last time I executed this command, I had more resources. These are the leftovers. These are the resources that were not yet deleted. Composites might be the best feature of Crossplane. I already explored in previous videos, check them in the description, the importance of Crossplane. It provides a universal control plane that allows us to manage everything with a single API. We can use Kubernetes definitions, Kubernetes API to manage everything. And everything can be things within a Kubernetes cluster. It could be clusters themselves, or it could be any other type of resources, networking, storage, whatever we might need to manage can be managed with a single API, and that API is Kubernetes API powered by Crossplane. Crossplane is effectively a universal API for everything. One API to rule them all. And on top of that, we can use composites to combine different resources and enable everybody to use our services in a simple way. Composites enable shift left. Ops people or DevOps people or SREs or sysadmins or whatever we call the people on the right can define complex operations in a way that is very easy to consume by everybody in an organization. If you look at AWS as an example, creating a Kubernetes cluster involves a bunch of resources. It is a complicated thing to do. And I use the simplest possible example. If you would add databases and storage and what's or not, those hundreds of lines of definition can easily become thousands. But we can combine all those resources. We can combine all those definitions into composite definitions that are easy to consume. Everybody, no matter their experience with infrastructure or anything else, can understand a few lines of YAML if we simplify it. And what is really amazing is that that simplification does not come from a software vendor. Because if software vendor decides, hey, this is how you deploy applications, this is how you do this is how you do that, our freedom disappears to define things the way we want those things to be defined. So we are having three actors here, three personas. We have Crossplane as an unopinionated way to create opinions. We have ops that deal with complexities and define the opinions themselves. And then we have devs or whatever we call people on the left side that consume those opinionated frameworks. You are in charge of defining opinions. You're in charge of deciding what is what and what is not. Yet devs have freedom within the things that interest them. So devs might not care about subnets, but they might care about, let's say, the size of the nodes or the number of the nodes and so on and so forth.